Hello, my name is Reader Ward, and this is the story behind my senior project. With college applications just around the corner, I wanted to have something that relates to my main interest, mechanical engineering, on my transcript. During my interactions with engineers, many have testified how the best mechanical engineers have a background in machining. This satisfied my desire to find something creative or unique to put on my transcript. As an aspiring mechanical engineer, I want to do all that I can to increase my work experience and expand my knowledge in different fields of mechanics to proportionally increase my value as an engineer. Because of this, I decided to make my senior project topic learning the basics of machining. What is a machinist? A machinist uses high-tech, cutting-edge machines to shape metals, plastics, ceramics, and even wood into something new. The machining process actually starts from a design stage, where a need is proposed to produce a part usually made out of metal. Mechanical engineers design the part using simple drawings and then transfer their ideas to a 3D modeling program, such as AutoCAD, to shape the part, produce its specifications, and to modify the part. Then, the blueprint of this new part is brought to the machinist to be made. There are two main machines machinists use for two different types of parts. The first one is the lathe. The lathe is used for any kind of part that has a rotating axis. Some common parts made on a lathe are parts with threads on them, or cylindrical pipes, or any sort of cut that requires a circular or rotational cut. The second machine is the mill, also known as the milling machine, where parts are made on a standard XYZ axis. These machines are both operated by a series of levers, knobs, and a rectangular workspace that is translated by rotating handles connected to a large lead screw. Also, each machine has a cutting tool in place to machine the metal part. Such as a drill bit, end mill, circular saw, bore, etc. Before the machinist begins to work on the metal part, they must find the center of the tool bit, or find its vertical boundary relative to the part being machined, in order to make accurate cuts in the metal. This is done by running a magnetic edge finder along the edges of the metal part being machined. Then, they machine the part, whether cutting slots or edges, drilling holes, milling a radius, etc. After each cutting procedure is finished, the machinist must deburr all edges that were in contact with the cutting tool on the part, since cutting processes often produce a burr that can make the part not be held perfectly square in the vise for the next procedure. And they must be measured to make sure each dimension is in spec. Some dimensions have to be within a couple of 10,000ths of an inch. That's actually a fraction of a hair's width. Once the part is completed, it is inspected again, deburred, buffed to produce a shiny, non-oxidized finish, and then washed. This senior project has taught me a great deal of things, not just about the field of machining and its ties to mechanical engineering, but also other things, like paying attention to safety while working with these machines, making sure to have good social skills while working with other employees, and developing my character traits that are important to have in the workplace, such as teamwork and diligence. And because of all these things, I am just very, very grateful for this experience, for my project consultant, and for the effect it will have on my career and my life. Thank you for watching.